Welcome back, Twitch. So usually, we have two co-hosts up here. So I feel a little outnumbered, I'm going to say, because technically I think we have two expert guests instead. Nikki's supposed to be a co-host, but really, she built a lot of this stuff. I'm really excited that you're up here. We've also got Richard here. We're talking about, we're not supposed to pick favorites at AWS, but this is probably one of my favorite services.
That's good to hear.
And you also took one of my most favorite people at AWS, too, so that even ups the ante here. But would you two please introduce yourselves?
Sure. I'm Richard. I'm an engineer for AWS Mobile, and I launched AppSync as well as the Amplify framework. And my day-to-day right now is basically kind of making sure that ecosystem kind of thrives and we deliver software.
Super cool.
I'm Nikki. You guys know me. I'm a software engineer on the Amplify iOS team.
That's right. We're here to talk all things new in Amplify. Is that right?
That's
and
right.
We've got some really cool updates around the ML space.
Yeah, so I don't know if you guys caught this, but we launched Amplify for iOS and Android, and specifically for iOS, we launched the predictions category. And the way that it works is really, really cool. So we have our online pre-trained models, recognition, poly, transcribe, the things that we know and love. And then we also take advantage of Core ML, which is Apple's machine learning framework. And Core ML actually runs on device, so those model inferences run offline. So when your device is online, we will actually call both models, and then we will union the results to get you the most accurate set of results and the largest data set possible. Meaning, if recognition returns X, Y, and Z, and Core ML returns X, Y, and B, you're going to get B back, and you're also going to get Z, as well as X and Y, with the highest confidence scores possible. So it's really, really cool, and you can also take advantage of just offline calls as well, but there is that seamless integration between online and offline inference on your device natively. So yeah, that's basically what it is.
Yeah, I'm really excited about the offline support, too. I mean, that's huge. That's insanely difficult to build. Anything offline is hard to build.
Oh, yeah.
Agreed.
And imagine machine learning offline to build that. But nope, it's just packaged up for you.
On the subway, no internet connection.
Yeah.
I just want to detect that image. I want to detect the labels in it.
That's right, and you gave that to us.
I did.
Usually we're more mean to each other, but I'm so
now you
proud.
gotta be nice.
I'm so proud.
You're so proud of me?
I'm so proud.
I don't think I've ever heard you say that.
I know, it feels weird. It feels weird.
Are you going to take it back? I mean, should I I need the recording of this video, someone.
No, it's live. It's lost to time. Never to be seen again, unfortunately. We also, we launched Data Store, too, right, Richard?
Yep.
We're going to talk about that in a bit, too.
I think Data Store is even cooler.
In all things Nikki, right, this is a demo-heavy session that we're going to do, right?
Of course.
Yeah,
Both
have
have demos.
We need to see some stuff.
Yeah, all right.
They just want to see the code anyways, right,
Yeah.
guys? I know you.
So take us away, Nikki.
All right, so we're looking at my laptop. We have some good old-fashioned Swift here. I actually built this app using Swift UI, so if you haven't gotten a chance to take a look at it, it's pretty freaking cool. And so I've loaded it up here, and I have these subcategories of predictions. So interpret, identify, and convert. And in the interpret one, I'm actually going to do sentiment analysis and natural language processing right here in the application. Again, taking advantage of that seamless online-offline inference. So I can say, hi, Twitch, what is up? And make that call. And here I'm displaying only some of the results for you. There's actually a lot more that you get back, but couldn't fit it all on the screen. So you get the sentiment here, which unfortunately is detected as negative. And then you also get the syntax, so every single word with the part of speech, which is pretty cool. And then if we move to something more fun like identify, we can actually identify a lot of different things in our images. So we can take a picture like this. This is cool because that's actually a picture of my stream kit. So that was what I took around with me to run Twitch streams. And so let's just do detect labels. And then all labels are displayed with their confidence scores. We can do something cool, like actually switch from auto, which is the default, to just offline to see what Core ML would return nearly offline, and rebuild. It's going to take a second.
We've got a question. What language is that? That's
Swift.
Swift. probably Nikki's top language now at this point.
It's pretty much always been my top language.
All right.
So this is actually an important point because all of the Amplify native libraries are written from the ground up in Swift. So older languages that we had in the older V2 SDKs were actually a blend of Objective-C under the covers with Swift. Now these are 100% from the ground up, which makes it really easy for customers to contribute in an open source manner.
Yes. Yeah, that was one of my favorite announcements too from this reInvent was that there was kind of some of the old mobile hub stuff still mixed in, but now it's all straight Android, iOS, Amplify.
Correct.
I love that. That's
100% the exact same patterns that we use in the rest of the Amplify framework.
Yeah.
So you can see here that CoreML only returned one label. It's really interesting to play around with it because in certain cases, CoreML returns more things than recognition, which is the service behind what's being called here. We can go to something fun. So you should be able to actually hear that. Hopefully you did. That was Holly, as we know it, speaking to you in a childish voice.
Who'd you pick?
Who do I always pick?
Justin.
That's right.
Who's also, it's your husband's name too. So there's something special
I naturally
about
select
that.
it. But it also sounds like a kid, so I always pick it because I want to hear it.
It's kind of creepy.
It is kind of creepy. Like, I like something about it. Anyways, so that's predictions in a nutshell. This app is available in my GitHub repo. It's called Swift Predictions. You can check it out. Check out how to use the Amplify Predictions iOS library. It's pretty cool. Again, bunch of things you can do here with identify celebrities, entities, text, and then there's additional things that I didn't show, but feel free to check it out. I actually want to get to what I think is the cooler launch from Amplify, which is Data Store. Richard, take it away. Tell us about Data Store.
Okay, so Data Store is a new category that we've added in Amplify this week, and this exists for JavaScript, iOS, and Android. And the idea was that there was a lot of solutions in the market that handled like offline behaviors or real-time updates, and we wanted to solve that problem. But another problem we really wanted to solve was like GraphQL is taking off. It's really huge in the industry, but if you look at how customers kind of build apps, and not even just pure AWS customers, but just iOS, Android developers, JavaScript, what ends up happening is they define their GraphQL APIs, and then their clients essentially become a function of their backend. And that really doesn't blend well with the ergonomics of a Swift developer or an Android developer or someone else.
Right.
And the idea behind Data Store really centralized around talking to customers to where they didn't want to deal with all these distributed systems problems where, honestly, clients, when it comes to mobile and web clients, are the ultimate distributed system, right? You have network partitions, everything about the CAP theorem applies. And the idea was, rather than pushing that complexity down to those developers to think about fetch policies or to think about updating caches, Data Store is not a cache, right? Just like you hear databases are not a cache. It is an on-device persistent storage repository. And the fundamental concept is I just define my data model as a developer. Maybe I add some authorization rules in or some business logic, and then build it in Go. And so the way that this works is, just to show you a little bit of an architecture diagram here on my device.
I mean, this is so powerful. Like, as an app developer, the number of times I've tried to do this myself, there's always bugs. Trying to keep the database online with my data store on my device in sync is incredibly difficult as an app developer.
Syncing data is always fun. Fun job, right?
Oh yeah, and not only that, so I'll talk about the Amplify Data Store architecture, but we've built a whole slew of new techniques into AppSync, which powers Data Store in the back end. So this is powered by GraphQL to automatically detect conflicts by the service tracking versions on each object.
Right.
Then it will do delta synchronization, and it even has some new techniques, and one specifically that we call auto merge, to use the GraphQL type information to get inference on the fields inside an object and automatically detect if there's conflicts and union and merge them together.
Right.
So it addresses some of the things in the industry, like you might have heard of, like operational transforms or CRDTs that are really hard to scale, but because we have GraphQL, we're able to do some clever techniques basically to get around these limitations.
That's cool.
Yeah, so this is the data store architecture. And the idea is you have a few key components. The data store API is what the developer interacts with. The storage engine handles marshalling between different databases themselves. So on JavaScript web apps, this is going to be IndexedDB. On iOS and Android, this is going to be SQLite. in a few weeks now that we've published the iOS and Android storage adapters publicly, we're going to have a React Native bridge that will use that exact same code base, so we get consistency across the platforms. And then what happens is, just to kind of show you the flow, developers, they do their data modeling with GraphQL SDL. So you can see type post here, name string. They run a build process. And we took this farther where we're not just making people manually run a command, but we plug into their IDEs. So now we have a Gradle plugin that's published, and you can just run a Gradle task, and it does this, and it generates Java POCOs and everything else, including step builders. In Swift, so cool. It's a CocoaPod subpod that then will edit their Xcode project, and then it's part of their build phases. We have an NPX task here too.
I mean, if you're not drooling as an app developer, like, I don't know what's going to make you drool.
And so they basically create these and then operate on this data store API. And you can see, like, I create a model instance here, and like I just do save, query, observe, real-time subscriptions, including this is using Combine under the covers in iOS 13 now for Swift.
Cool new framework, you should check it out.
We also have this nice Fluent interface that you can see this C.rating there, because as we take these GraphQL models and we do this code gen process, we are able to see the type information there from the developer experience and do things like, if I were to show you here in an app, make this a little bit bigger here in some code. I will. This is a TypeScript project. So if I did await data store, and I was going to do something like query, you can see here I've got like all my fields here. On my type is on the left. I've got title, rating, status, tags. So if I wanted to look at something like I don't know, let's look at the rating, right? And now I open it up and you see all the different operators, right? Because rating here is an integer, so I can get like equality and less than and things like that. But if I had been switching on, let's show the tags here, which is a list of strings, I'm going to get operators like contains and not contains.
Oh, nice.
So this Fluent interface is dynamically generated, and we have the same thing on Swift and Android as well.
Very nice.
Or I should say Swift and Java as well. So this architecture that we've built here, what ends up happening is, at runtime, inside the library, we take what we call these models, right? And the data store API uses some information on the different platforms. So on Java, we use a reflection with Java annotations. We use what we call a model schema in JavaScript. Right. And on Swift, we actually attach these to Swift classes themselves with some metadata and protocols. And the storage engine, like I said, does that marshalling for the storage adapter specifically. I'll call out, just using data store right here, no AWS account needed. If you don't want to hook up,
I'll store it in the native, core data or SQLite.
That
SQLite, yep. No, so if anybody wants to use this without even syncing in the back end and you just want a really robust solution for data modeling locally in your apps and you're storing data, 0 AWS account needed.
That's awesome.
Now,
so cool.
If I were, though, to flip a bit in like my Gradle definition or my Xcode configuration file, I build my project again. And from application code now, we create the entire backend. So we create AppSync backend, we create DynamoDB tables. If you had annotated your schema with @auth, we create all of that. And then another sort of conversion and serialization and deserialization starts happening. We take those models in the model registry from the storage engine, and this sync engine component that's now observing the storage engine converts these to GraphQL statements, makes the appropriate queries, mutations, and subscriptions, and then when it gets responses, does the reverse serialization all back to Java, Swift, and TypeScript types.
All through AppSync as well.
Yep, all through AppSync. Yep.
That's amazing, yeah. I mean, like what I really like about it is if you're writing GraphQL applications, right, you're already writing schemas, you're used to this type of model. Even, I'd say, further back, if you're writing MVC apps, you're writing models, right? Like, these are things that are not new, right?
Oh, yeah.
These are just ways of making it so much easier to connect directly your data store and your models.
Oh, yeah.
It's really interesting.
And so let me talk about one more thing right here at the end. So we've got some Delta Sync and stuff like that. But a cool thing that I want to show is this auto merge concept. So auto merge is basically a way where AppSync, now this is specifically in the AppSync service, is controlling these versions on items and things like that. So as you're writing, it's writing to Delta tables and basically manage that whole orchestration. And this is what gives us nice consistency throughout the system. When I talk about the system, I'm talking from back end to clients. And because we have GraphQL type information, if you look at this slide, like my original item in the upper right-hand corner is an object called with like a dog, like Shaggy, age is 6, breed is Beagle. And you can imagine if I have concurrent updates from 2 clients on the left, where one is changing the age and the other is changing the breed, we can tear apart those types at runtime, look at these versions, and union the results, so neither client loses their updates.
Wow.
You also saw when I was doing that little interface, I can apply conditions to mutations.
Yeah.
So if I wanted to, on one of these clients, do a mutation and preserve one of those conditions, I can do that right there as well. And it works as well, not only just for scalar types like you saw there,
right,
but it works for lists as well. So lists and sets.
Oh my God.
So in this example, the original item, Shaggy, he's a miniature schnauzer, right? And his interests are toys. But other clients also want to give Shaggy interests of cats and dinner. And so the union of the results here is concatenated list. And then if you wanted to use a set, we could dedupe the information. So let me show you this in action. It's pretty cool.
That's cool. That is very cool.
That is insanely cool.
So let me make this a little bit bigger and zoom in. All right. So this is the app you just saw. I'm doing a list of the back end here. And I'm going to create an item. And actually, you can see on my clients here, I don't have anything on them. Actually, if I wanted to do Nikki iOS demo, and I'll put a tag of Swift, I'll create an item here. I'll do AM. I'll make this one rejected.
Yeah, that's about right.
Create.
Seems
and
legit.
let me do 8. And
Seems like something you're familiar with.
I'll put Natter on here. And Natter's going to be in published.
Oh,
and
wow.
he'll be React. So these are all going to the back end, as you can see. And if I come back over here on one of these clients, I'm going to actually show 2 clients here. You can see it, my second client was already getting these updates here. Let me just, because I didn't have this one up on the forefront of the screen. Oh, I know why. Because I didn't actually, I left out one of the fields here. Let me delete these and refresh this. There we go. So I'm going to actually show you how to create an item here from the console. So I'm going to do Nadia loves naps, OK? Her tag is cats. So I come over here to the clients, and you can see they've both gotten them.
Wow.
And right now, what I'm going to do is on the left-hand side, I'll take this same ID to show you an example.
Is the source code for this anywhere online?
It's on my laptop right now, but I can put it online.
The best
There's some
version
requests for
control
that.
system.
And I will put dogs here. So you can control how you want the conflict resolution to happen, whether you're going to append the item or overwrite. In this case, I'm going to do an append one. Okay, cats, dogs, you can see real-time subscription came through. I'm going to do a list of that item, right? Cats and dogs. Now here's where it gets cool. On this right-hand side one, I'm going to go to the network tab and make this one go offline. Okay? Now, on the right, I'm going to use that same ID, but I'm going to put birds with 1D. You can see this was an overwrite because that's offline.
Right.
If I do a query on the back end, item didn't change.
Nope.
And so now I come over here, and what's another one that I want? Mice. So I've got that data. That's in the back end already. And now if this client comes back online, it's going to synchronize up, and you can see network refresh is going.
Yeah.
And we actually unioned all the results without losing any information because AppSync got the type information, decomposed
cool.
it, looked at the fields, and then concatenated the info.
That's pretty amazing. I could talk to you both all day, which I've often talked to you all day. So, but we can't. We have to move on to the next session, unfortunately. Thank you both for joining, and stay tuned. We've got more content coming.
Bye, everyone.